Welcome to this webinar. In the next 45 minutes, I will show you how to create a software pack that can be shared with developers either internally or externally. My name is Christopher Seidel. I'm Technical Marketing Manager in the Development Solutions Group at ARM in Munich. CMSIS-Pack describes a delivery mechanism for software components. It simplifies the usage of external source code for application development. The XML-based package description file describes the content of a software pack and can include software components made up of source code, header files, libraries, and code templates, documentation in any form, PDF, HTML, doc, device parameters, example projects to be used with certain development boards, or the microvision simulator. The complete file collection, along with the PDSC file, is shipped in a zip format as a software pack. At the top of this page, you find the documentation. It's under www.kyle.com/CMSIS/pack. Let's have a look at the steps that are necessary to create a software pack. First of all, you need to create the input that will be shipped with the pack, so the source code, header files, documentation, and all that is part of your software component. For better maintainability, you should think about good structure to organize this input. So, for example, a suitable folder structure. Then you need to create the PDSC file and match this structure to the elements that can be defined in it. While writing the PDSC file, you should already verify it against its schema file to avoid unnecessary loops in the next step. This is finally to generate the pack. For this, we have a tool available called PackCheck, that helps you to verify the pack's integrity and check for any problems with the pack. In this webinar, we are going to create a software pack for Jansson. This is an open source C library for data exchange using JSON. Together with an embedded web server that is, for example, available with the MDK professional middleware, it is a powerful tool to create AJAX web content. As you can see on the right, I have categorized the content of the software pack. It will be the first release of a pack called Kyle.Jansson. So the vendor will be Kyle, the name of the pack is Jansson. The release version will be 1.00, and it will have a software component called Data Exchange Jansson. And this software component will be made up of the libraries files as they are available on the web, plus additional C libraries that I have created out of the source code. So let's have a look at the first files that are available on the web. So if you go to the Jansson web page, there are two files that can be downloaded. First of all, this is the Jansson zip file, which contains the documentation. And you see it's an HTML-based documentation, and most of it is in this _static directory. Later in the pack, we will add to this documentation a license file that will be shown when installing the pack. The other thing that you can download from the web is the Jansson tarball. I open it, and here are a lot of directories and different files, and actually we only need this source directory, which contains all the source and header files that are required for the pack itself. Also, there's a Jansson config.h file in it, which I have changed to some extent so that it matches the requirements for an embedded project. So you see, basically, you can download from the internet these two zip files. Now let's have a look at how I have organized them. So I have created a doc folder which contains the documentation as you saw it in the zip file, plus this license text file. I'll quickly open it. So this license text file just contains the MIT license that is used by the Jansson pack or by the Jansson library. The examples directory contains an example project that we will use in the software pack to demonstrate how to use this library. I show this later when the pack is installed. The lib directory contains the two libraries for ARM v6m and v7m architectures. I have used a batch script to build both libraries. And the source directory contains all the source files that are available also in the source directory of the Jansson tarball. So now let's start creating the PDSC file. Because as I said, a pack file is basically a zip file that contains the data that is to be used for the software components and the so-called PDSC file that describes this content so that it can be used by development tools, in our case, Microvision. I use an empty template file to start writing the PDSC file. So you see here in the pack name.pdsc. Let's have a look at it. This PDSC file, this template file, is part of your ARM CMSIS installation, but I will also share it with you during this webinar so that you can save it where you like. So a PDSC file usually starts with the XML version and encoding. That's as other XML files do as well. And then we have the package element that declares the schema version and the XSD file, so the schema file, like here, pack.xsd. And here's a tip. Use an editor that is capable of XML validation while writing the PDSC file. As you can see, I personally use Notepad++, which has a corresponding XML plugin. And in this folder where I have the PDSC file, I have also the pack.xsd file. So I have copied it there so that Notepad++ can verify the PDSC file while writing against the schema file. This pack.xsd file is part of your Microvision installation. So usually Kyle v5, uv4, and then you see the pack.xsd. Sorry, it's down here. Yeah. So after the package element, we have the vendor element that specifies the vendor of the pack. In my case, Kyle. Then the name, which will be Jansson. The description describes the pack in a few words, and the URL defines the download URL of the pack, but can be empty if you don't put it on any web server and just have it as a local pack. The license links to an optional license file that I have also added to the doc directory, and release information in this releases section that will be used for determining the pack version, and the display of release information as a tooltip in Pack Installer. So let's fill this out. As I said, we are here, the vendor is Kyle, the pack name is Jansson, and as a description, I have prepared something. So it's a C library for encoding and manipulating Jansson data. Our pack is available through our web server, so it's http www.kyle.com/pack, and as support contact, I'll use support@kyle.com. And as I said, I will use a license file, so I take out the comments and add the license txt file here. So for those of you who are Windows users by heart, you will notice that I have used the / as a delimiter in for the folder. So this is intentionally because we aim to have the packs also available for Eclipse users or for tool users who are using tools based on Eclipse, which might use them in a Linux environment. So in this case, we are adhering to the standard. Also, you have to be aware of upper and lowercase letter writing. So pack installer will automatically change these / to / to be used with Windows. And release notes, so it's version 1.1. We say it's initial release. Okay, keywords. You can specify keywords for indexing or search engines. I will, for now, just put in the keyword Jansson. So there are different other sections that are mandatory for some packs. So you see a board section if you are creating a board support pack, or a devices section for device family packs. What I would really like to continue with is the conditions section. So with conditions, you can describe dependencies on a device, processor, and tool attributes, as well as on the presence of other components. And these conditions are used to define and or rules used to make components conditional and therefore only available under certain circumstances. And let's have a look at the conditions that are used here. I'm copying this now from original file. I have 3 conditions, and these conditions, they have each condition has an ID, so a unique identifier that is unique within the scope of this description file. And this ID can be referenced in the condition attributes of components, APIs, examples, and files, and other conditions, so to become conditional. And we have 3 different attribute sets. So we have accept, as you see here, we have require, and there's an additional attribute I have not used here, it's deny. And of course, the complete condition, or all these attributes, have to become true so that the complete condition can become true. So what do we have here? I have a condition for ARMCC, so I require the ARM compiler, tcompiler ARMCC. That is because my 2 library files have been compiled with the ARM compiler. And then I have 2 different conditions to filter for either ARM v6m devices, so M0, M0+, and the secure core devices, or the ARM v7m architecture, so M3 upwards to M7 and the secure core 300 devices. And the actual software component is then defined in the component section. And as said, this like this. Let's do it like this. So the component, each component element describes a software component that is contained in the pack, and each component itself lists all the files that belong to it. And the component itself or each individual file can refer to a condition. Each component must have a C class and a C group to describe it, and also a C version, just to say which version this is. And optionally, you can also have a C sub for a subgroup, and a variant, for example, if you have differences in debug or release versions, for example. So I have the component C class data exchange, C group JSON, and the C sub Jansson. It's the current version is 2.70. I have used this version number because this is the library's version as it is available on the web. And you see it requires the condition armcc because I'm using these two library files. And in this file section of the component, I have different files. So the category doc, I refer to the index.html file for the documentation. I specify the header file of this component, and I also specify that I have a configuration file called Jansson _config.c that has also a specific version. So this is because if you are changing the component later and you get a new C version of the component, your configuration file does not have to change necessarily. So sometimes you do change the component, you add something, or you make some bug fixes, but the configuration file does not change. So then you could, for example, stay with the version of the configuration file as it was before, although you have counted up the C version to, let's say, 2.8.0 version. And here you see how we can filter using the conditions for different devices. So here are the two library files, category library, and they have the different conditions, v6m or v7m device, and depending on which device I use in my project, I will either add the Jansson CM0le.lib or the Jansson CM3le.lib. And I use the tag source to tell the debugger where to find the source code for the libraries. So that debug symbols can be created and debugging will be possible just in case that something went wrong. So this is the component, and scrolling up a bit, here's the examples section, because every good software pack should contain at least one example project so that the users who are not familiar with the component have a pre-built example to see how it actually works. And I have prepared an example project as well. So this example name is called Jansson example. It has an abstract.txt file, so a kind of documentation. It's contained in the folder example. And every example has to specify a board name that it's associated with. I will show you later in Pack Installer how this works, but so either using devices or board names you can filter for example projects. In this case, this example does not even need to run on a development board. We have specified a board called Microvision Simulator, so it runs within the simulator. And then I specify the project file. So under example/Jansson example UV project, that is the UV project file. And that is already basically it for my PDSC file. Maybe one thing worth to mention. Let's go back to the slide deck. This one I showed you all live. So here's a hint, because I often get the questions, well, how do I create example projects for a pack? So because example projects adhere to the chicken and egg problem. As long as you don't have the pack, you cannot use the software components from the pack in the example project. And as long as you don't have the example project, the pack's not completely ready. So the hint is actually first, of course, create a preliminary pack with the required components. Then you create an example project using the pack and its components. Then you add this example project to the pack and publish the pack. Sometimes you see below there it's stated loopback is required because sometimes you might see that the partitioning of the software component needs to be changed when you use it in a real-life example. That's also one of the reasons why you should always add an example project. It's just to test the software component for yourself. Finally, I save the PDSC file and so that I can start to create the software pack. Let's do it here. So yeah, I have saved it already. I will close it now because I will rename it, because also the name of the PDSC file needs to adhere to what you have specified within the PDSC file. So I said the vendor is Kyle and the pack name is Jansson, so I change it to kyle.jansson.pdsc. This is also especially when I start using my generation batch script. Let's have a look at this one. This relies on the fact that in this generation folder there should be only one PDSC file available, so it's not really checking if you have multiple PDSC files, or it does not check which PDSC file to use. It will just use the next available PDSC file. So before showing you this, so this batch script, the genpack bat, is available. That helps you to check and generate the file. It is located within also the pack documentation. Nevertheless, I will just share it in a few seconds with you. And this batch file will check the availability of the PDSC file, so it will just do a sanity check. Is the PDSC file available? Then it will copy the PDSC file to the files subdirectory, run our pack check tool on the file subdirectory, and create the pack file in the working directory. So let's have a look at this. So first of all, it just checks for an error log. Then it checks if there's only one single PDSC file available. It uses the name of the PDSC file. That's just for an intermediate step. And it copies the PDSC file to the files subdirectory. And here it calls the pack check exe from the files directory to check actually the PDSC file against the contents of the files directory. If nothing has gone wrong, then I create the pack name out of something that I have stored up here, and I zip basically all the stuff in the files directory together and name it kyle.jansson.1.0.0.pack. So let's see this in action. I will just open a command window so that we really can see what's happening here. I call the genpack bat, and here it is. Let's scroll to the beginning. So first of all, it says, okay, could not find the error log because I have not run it already. Then here's our pack check tool. First it says, okay, phase 1, read the PDSC files. Phase 2, static data and dependencies check. In this case, we have only one warning in the PDSC file because it says examples found but no board description found. This is true. I have added the examples section, as you have seen, but I have not added a board description because I rely on the board description that is already in the ARM CMSIS-Pack. And then we do some model-based data and dependency check, and there are no further errors and warnings. So I can call 7-zip to compress everything into the archive kylejansson100.pack. So you see here long compression, and if I go back, I see here is the pack. And simply double-clicking installs this pack. Okay, in my case I have it already, but nevertheless I install it. Then you see the license agreement is called, this MIT license as I have added. I say I agree, next, and then it installs this pack. So now before actually continuing, first of all I would like to share the link. I have packed up the pack XSD, the pack check exe, the genpack file into a zip file, and I hope this works now. I send you the link. So under this link that you now see in the chat window, you can download the zip file which is called takeaway.zip. So we can also, is it here? Yeah, takeaway.zip. So I have put in the Genpack batch file, the schema file, the latest pack checking tool, and this empty PDSC file so that you can use it as a reference. While you looked at this, I would like to ask you a question. So here's a poll. Hope you can see that now. Yes. So maybe just give you a few seconds time to think about this. Okay, I close it now, and let's have a look at the poll results. So what do I need to verify my pack? Please select all that apply. Of course, I need the, well, need is useful tool is the Genpack batch script, that's correct. I need the pack XSD to verify my PDSC file. I need the pack check exe to verify the complete pack later. I do not actually need the pack installer to verify the pack. The pack installer is required to install the pack in your tool. So the last one is not correct. The other three tools or files are required. Okay. So I hide this, and you should see my screen again. Yes. So let's go to pack installer. As I said, I have added an example for a board called Microvision Simulator. So here it is, Microvision Simulator. If I click on it, I see in the Examples tab down here, there's my Jansson example for the Microvision Simulator. We have a small tooltip which says which board it's used, which device, and from which pack it's coming. And using this copy button, I can copy it to a destination folder. So in this case, for example, C projects, I hit OK, and automatically also Microvision will be launched. And here's the complete project using this pack. I have my configuration file here available, and as you see, the components do have different icons. So this icon means that this is a library file, and it is pulled into this project as read-only, because you should not and cannot change it. The configuration file does not have any icon, so you can write it as you like. The same for the other files. The small one I will explain just in a minute. Here we have an extract that explains how to use this library. We have an application note available under this link that shows how to use this Jansson component with an MDK middleware HTTP server. So this is just to show how you can use the built-in example projects to get your end users to quickly getting started with your software pack. But all these built-in mechanisms with the software packs, they can also give you much more advantage, because especially when thinking about versioning, version control, and updating software packs, this is a very handy tool. So I will close this project and select another one. I will search here for MCB 1800 because it's one of our microcontroller boards based on an LPC 1857. There you see we have different example projects as well. And I will take a slightly sophisticated one, our HTTP server, and again copy it to see projects. MDK opens, and you see, oh, there must be something wrong because this network bubble is red. So also the build output down here tells me, okay, error instantiating RTE components, error KyleMDK Pro network core release 6.650 is not available for target. 650 is not selected. So what are we doing with this one? We open the Manage Runtime Environment. And this Manage Runtime Environment window helps you to select all your software components. So for example, here you see the data exchange Jansson. I could add or I could remove as we like. And I see that the network has some problem here. And I see component is not available for target LPC 1857 flash. So let's have a look what is available. Here the component release is selected, but it seems we have IPv4 v6 debug or release. So let's put that to release, and ta-da, suddenly everything goes green. This component is available and I can use it in my project. The validation output window is clear, so everything is fine. And I say okay. But then I still see, okay, the network has some problems. So these small icons tell you that a configuration file that has been copied to the project is not compatible anymore with the previous version. But also for that, we have a built-in mechanism to overcome this situation. If you right-click on this configuration file, you have two options. So simply update the configuration file from 504 to 700. Or you can even say update config file and launch merge. In the tools menu, you can now configure a merge tool. So you can tell which kind of merge tool or diff tool or whatever you would like to use. In my case, I use WinMerge, or I have configured WinMerge. So if I go to update config file and launch merge, it opens this merge tool, and I can directly see the differences between the two configuration files. So most of it seems to be not so drastic, but here we see, okay, a complete new section has been added to the new file, because the new file is on the right-hand side, and this was missing before. And using this mechanism, I could now go line by line through my config file and save all the configuration settings that I have used before. And as soon as you then save this right-hand side file, you have them already in the project. I close this now. You see we have updated the config file, so this red boxed X is gone away. The easier version is to say update config file. Then it also will go away, but you will just get the blank or the standard configuration file that is available within your software pack. So all the settings that you have done before will be gone. So be careful when just saying update. Usually it's better to have a look and use a merge tool to update it. Another thing, how you can also use it, I will just once again copy the same project, HTTP server. It says destination folder not empty. Do you want to copy anyway? So basically, do you want to overwrite? I say yes. Because this incompatibility comes now, I have installed a very latest middleware version, in my environment. So I'm using the MDK middleware 7.0.0 beta release that has the IPv4 v6 support. But I could also use another one. Here's another icon, select software packs. So if you click on that one, you will be presented with all the software packs that are installed in your runtime environment. And usually it says use latest versions of all installed software packs. And if I uncheck this one, I can actually select which version to choose. So if I go to Cal middleware, I can choose instead of the 7.0 beta 1, I can use the 6.5. I uncheck this, so now it's fixed to 6.5.0, and I say OK, and suddenly this bubble goes also to green, and I don't even have a configuration file problem anymore because the 6.5 version is compatible to the 6.4 version which was used to create this example project. So you see, using all these version information in the files and in the software packs together with the tool gives you a very powerful option to work with your project, with your software components. You have the ability to automatically resolve issues or to have tools at hand that can help you resolving these issues manually. So this should conclude the small demo. Let's continue with the slide decks. And as we have seen, a double-clicking on a pack file will install it in MDK. But how does pack publishing work in general? So basically, you have 4 choices how to distribute a software pack. The very first one is what we have seen, the local installation. So you could, for example, send it to a user or to a fellow engineer via email or something, and he can save it to his PC and install it locally. So this is the local installation. Or if you're working in a larger company, you could, for example, use an internal file server for the distribution. So it would be available to all users that have access to this file server. The third way would be that you upload the pack to a web server, to your web server, and distribute only the link to the pack within your peer group or customers. So if you add the URL element in the PDSC file, as I have done with the Jansson pack, this pack file will also be updated automatically by pack installer. But in principle, still this pack is private as the URL is not generally known. And if you want to share the pack with all users of MDK, so you can ask your pack to be listed on our pack index server that is used by a pack installer to check for available packs. So the website www.kai.com/pack is used by pack installer to search for available software packs. And we are very happy to add your software packs to this index. So they will not be downloadable on our server. They will still reside on your server. It will be just that the index server will point to the pack or to your web server where the users could then download the software pack. So, as I have shown, the generation of, for example, the Kai Jansson pack was quite easy. And as I have done it is only one of the possible ways. So this pack concept is very flexible. Remember that by having the PDSC file, you can organize the input file as you like. And you will anyway specify for the tools where is what, so actually the folder structure, by using the file element. You can also use your own taxonomy, so avoid using, for example, a C class called Acme Corporation, because this will clutter the RTE window if everybody just uses a C class, his own company name, and does not really help the customer when selecting the right component for his problem. So stick to something like RTOS or wireless or yeah, as I have used data exchange, so something that is speaking for itself. And as you start using software components, especially the ones that you have created yourself, you will see how much work is saved when doing this. So it's really a big benefit for your daily work. And the final word, conditions are good for filtering, but too much filtering will make your component being invisible to most users. So usually filtering on cores or architectures instead of devices is perfectly enough, because normally most devices that share the same ARM core can use a certain piece of software, as long as you not rely on special hardware feature for a very certain device. So this actually concludes the webinar. Here are some helpful web pages that give you details on the topics that have been covered in this webinar. The slide deck is now available in the handout section, or will be available in the handout section in a few seconds. And now I'm very happy to answer your questions. So let's have a look. So, okay, slides are available. Not now. Michelle, can you please upload the slides to the handout pane?
They're just being uploaded now.
Okay, great. So there was one question, can I use a company-wide file server for internal pack distribution and updates? Yes, so as I said, this is one of the options, and you can also really use the URL component or the URL element in the PDSC file to specify the location of the file server. So if you specify something like file and then / wherever the file is, Pack installer can really pick up this file server location and can update files from there and update software components from there. So how to combine a software pack with an own BSP to reflect a special and own. So you can, let's switch to the PDSC file. So the PDSC has a board section, and in this board section you can also specify your own development board. You just need to specify a name and a vendor, so let's say my own development board, and vendor will be your company name, and then you can use this board name and vendor down here to, let's say, stick the example project to your own development board. So this is actually fairly easy, and you can also then add board support components, so that components that are used down here you can use them together with conditions to filter for your own development board. Maybe there's a special app note how to generate own BSP and software packs. We don't have an app note available, but I can show you the pack documentation. So if you look here, again, it was kyle.com/CMSIS-Pack, which will be redirected to this one. There we have a complete tutorial that tells you how to create software packs with all the different use cases, so for device support, board support, and for example, also especially a pack with board support, and this is then explained in all the steps that are necessary. So you will find that under kyle.com/CMSIS-Pack. Another question was, can I import a package directly in the package manager using the pack URL? So by package manager, I suppose you mean pack installer. So for pack installer, to first install a pack, you would need to double-click the pack, and if then there's a URL in this pack or in the PDSC file, then you will then pack installer will be available to pick this pack from that location. Another question, where can we find documentation of possible conditions? Yeah, the question, again here in this the documentation, we have here also the documentation for the different elements, how the conditions are made up, and so here it is a little bit explained on the conditions you can have. These things like decor or devender, these are also part of the documentation, so you will find it actually in the documentations.